could potentially find within the transformer. And the analysis of these gases is called dissolved gas analysis, or DGA for short. Generally, if your transformer does not have any
sound आ रहा था ना?
Yes, sir.
Yes, sir.
any faults, then you should not be finding any large pockets of gas coming from the transformer tank. But what does happen is, when we do have faults within the main electrical transformer tank, so this could be between the windings and the core or between the windings themselves, those small electrical discharges will heat up the insulating liquid, and it will cause the insulating liquid to break down. And when the insulating liquid breaks down, it actually produces gases. Now, the severity of the breakdown dictates which gases are created. In other words, if you've got a high energy discharge, this means quite a large fault within the transformer, what you'll actually have is a production of, for example, acetylene. Now, acetylene and ethylene, they take quite a lot of energy to make. That means you have to have quite a large fault within the transformer, and that is what creates these gases. When you have lesser faults, or faults with not such a large amount of energy, then you'll produce different gases. But the key point to remember here is that any fault, small or large or medium, is going to create some sort of gas. Now, the amount of gas is very interesting and worth analyzing. So you may get a slow trickle of gas coming out of the transformer, which means you have a low partial discharge maybe within the transformer itself, and this low energy fault creates gradually more and more gas. However, you may also get a very large fault, and this sudden fault creates a lot of gas very quickly. So let's have a look how the Buchholz relay protects against this type of situation. So let's go over to the left here. We've got a upper float, which is this one here. We've got a lower float, which is this one here. And then we've got a baffle plate, which is this red thing pushing the lower float down here. So let's imagine for a moment, we'll go back up here to our notes. Large electrical faults, the upper float maybe drops, the lower float drops, the baffle plate pushes the lower float down. So that's the first kind of fault we're going to have. This is going to be a large electrical fault. And what's happened is this large electrical fault has created a lot of gas in a very short amount of time. And because this gas is racing down the pipe, what it's going to do is impact with this baffle plate here. You can see it's got quite a wide sort of edge on it. It's going to push against that baffle plate, and then that is going to force the lower float down. So a massive inrush of gas pushes the baffle plate down, pushes the lower float down, and then that is going to shut down the transformer. Notice I said shut down. Obviously, there's going to be an alarm as well, but we're going to shut down the transformer because that is telling us that if the upper float is up and it's just the lower float down, and the baffle plate, which is sort of pivoted and pushed the lower float down, those combinations are what tells us that that is a big fault and we need to shut the unit down. However, there's other faults that we can also detect using the Buchholz relay. Again, we're going to use different combinations of floats and the baffle plate. The baffle plate itself is now no longer used. It's only there to detect large electrical faults and to push the lower float down. So now what we're going to use is the upper and lower float. I'll just push play again. Okay, so now we've got small electrical faults. I'll zoom in so you can see that. Upper float drops, lower float, no movement, baffle plate, no movement. So what's happened here? The baffle plate hasn't moved because what's actually happened is the lower float has dropped. And the reason it's dropped is because the gas has been slowly trickling in. You can see here it says small electrical faults. So this small electrical faults, let's just imagine it's a winding to winding maybe. It's slowly over time just kept trickling gas in. And as the gas has kept trickling in, it's built up within the chamber until it's moved down, 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 down. It's displaced the liquid. And as the liquid's been displaced, the float has dropped down because the float is buoyant. So the float has dropped down, and that has then set off an alarm. We can see here the two contacts at the top and contacts at the bottom. And those contacts, when they're separated, will set off an alarm. So we know now that we've got a slow accumulation of gas, and that has set off an appropriate alarm. Notice that I said here alarm. We're not going to shut down the transformer at this stage. We just know, okay, the transformer has obviously got a fault, and we need to find out what that is. So what we'll actually do is we'll go up here and maybe we'll bleed some of the gas off using this valve, and we will then send that gas off for analysis to determine how severe the fault is, and different gases also indicate where the fault is within the transformer. For example, carbon monoxide or CO2 is typically associated with the transformer insulation or the winding insulation. Paper insulation or cellulose insulation is also what it's referred to. So we'll analyze that, and then we'll get a better picture of what's happening within the transformer. Now, if we go back out, we've got one more type of fault. Let's just push the play button again. Okay, low insulating liquid level. Upper float drops, lower float drops, and baffle plate, no movement. So again, different combination here, but a different kind of fault. So low insulating liquid level, upper float drops, lower float drops. And the baffle plate we can ignore, because like I said, it's only used for one type of fault. You just make sure that's played to the end. Okay, I'm going to back that up a second, just so I can show you what happened. So this type of fault, see the lower float has dropped. So now we've got an upper float that's dropped and a lower float that's dropped. Now the upper float, if that had set off an alarm due to gas, what would happen is the lower float would not drop, because at some point the gas starts to trickle into the conservator tank we can see here through this pipe. So what will happen is the lower float will not drop due to a small electrical fault within the transformer and the gas accumulating over time. However, it will drop when the liquid level within this pipe drops low. Now remember, the tank, if we go back to our model over here, the tank is below the Buchholz relay. And what you have to imagine is below this section here, or below the top of the tank, everything should be covered in the insulating liquid. That's why it's called a liquid immersed transformer. If I go inside, actually, I might be able to show you. Yeah, we can see the connections here from the bushings. So this whole tank, this whole area should be totally flooded with liquid or insulating liquid. If, however, we set off that float alarm within the Buchholz relay, then we've got a problem, because we know we're losing liquid. And that is a big issue that could lead to what's termed a catastrophic failure, and that's what we don't want. So what we'll do, we'll have this second lower float here, and that will set off an alarm. In fact, it will actually set off an alarm and shut down. So this is another shutdown trip. Remember, the baffle plate pushing the lower float down was one shutdown, and now we've got two floats dropping together, the top and the bottom. That's another shutdown. So this is a shutdown scenario, and it means we've got low insulating liquid in the transformer. If that happens, then we have to take action immediately and find out what's going on.
हेलो हेलो
यस सर।
कोई दिक्कत? जो मैंने बोला मोटा मोटी वही बोला, थोड़ा एक्स्ट्रा गैसेस है और थोड़ा अंदर का वर्किंग प्रिंसिपल बोला। कहीं पे कोई प्रॉब्लम था? हेलो
सर, बफर प्लेट का कॉन्सेप्ट नहीं समझ में आया।
बेफल प्लेट?
यस सर।
बेफल प्लेट ओनली फॉर लार्ज फॉल्ट्स, लार्ज प्रॉब्लम, मतलब जब गैस ज्यादा होगा मतलब यहाँ पे सॉरी, जब देखो कैसे बताइए तुमको, लार्ज इलेक्ट्रिकल फॉल्ट में क्या होगा, नीचे वाला जो फ्लैप है तुमको क्या बोले थे पिक्चर में, तुमको डायग्राम दिखाए थे कैसे समझ में नहीं आया? अरे
सर बीच बीच में आपका आवाज कट रहा था तो क्लियरली नहीं समझ में आया था।
अच्छा रुको, ये वाला छोटा सा चीज इसको तो डायग्राम में ही बोला था मैंने। ये देखो लास्ट लास्ट प्रॉब्लम में क्या होगा, ऊपर का तो जाएगा ही, लास्ट प्रॉब्लम जो होगा नीचे से यहाँ पे एक्स्ट्रा गैस आएगा, ये बैफल प्लेट इसको, ये जो बैफल प्लेट सीधा रहता है इसको धक्का मारेगा, इट विल बेंड बैक, फिर इसको ऐसे प्रेशराइज करेगा तो नीचे वाला भी ट्रिप हो जाएगा। देखो इसको देखो, वीडियो देखो, लार्ज इलेक्ट्रिकल फॉल्ट अपर फ्लोट में भी ड्रॉप्स, अपर तो होगा ही क्योंकि ऊपर तो कम गैस जाएगा, तो लोअर फ्लो ड्रॉप्स कैसे, बफल प्लेट, यहाँ पे बफल प्लेट ये है जो डायग्राम में था, यहाँ से गैस घुसेगा, बफल प्लेट को धक्का मारेगा, धक्का मारेगा तो क्या, बफल प्लेट पुशेस द लोअर फ्लोट डाउन, लोअर फ्लोट ये है, इसको धक्का मारेगा, ये नीचे चला जाएगा, सेम, ये लोअर फ्लोट है, ये अपर फ्लोट है, लास्ट फॉल्ट के टाइम ज्यादा गैस आएगा, इसको धक्का मारेगा, इट विल पुश, ये धक्का मारेगा तो ये सीधा रहेगा ना, धक्का लगेगा तो इट विल बेंड बैक, इसके ऊपर प्रेशर डालेगा, ये ऐसे आएगा, इसके ऊपर प्रेशर डालेगा तो लोअर फ्लोट नीचे हो जाएगा, सर्किट ट्रिप करेगा, सिंपल है समझ?
ओके सर समझ में। यस सर।
हाँ ठीक, और कोई किसी का कहीं पे इसका ऑपरेशन में, ये इसमें सिर्फ इसका ऑपरेशन है, ठीक है। इसके बाद वाला वीडियो में तुमको ये दिखाएगा कि जो मैंने बोला जो गैस घुस रहा है, गैस घुसने की वजह से, कम गैस घुसने की वजह से अपर फ्लैप, ज्यादा गैस घुसने की वजह से लोअर फ्लैप, वो वाला दिखाएंगे। और एक और वीडियो उसमें तुम मतलब रियल लाइफ तुम अगर यूज करोगे और ये क्या कहते हैं बखौज रिले, वो कैसा दिखेगा वैसा, वो वाला दिखाएंगे। इसमें और कोई किसी का प्रॉब्लम? हेलो, नहीं है ना? क्योंकि इस, अच्छा ठीक है, इसमें सिर्फ इसका ऑपरेशन है बस। और एक चीज तुम लास्ट में सुने होगे, ये यहाँ पे बोला है कि एक अलार्म बजेगा, आफ्टर द अलार्म इट डजंट ट्रिप द सर्किट, इट डजंट, मतलब ट्रांसफार्मर को इट डजंट डिस्कनेक्ट द ट्रांसफार्मर। उसको लास्ट दिन कोई पूछा था, कौन, असीमा शायद पूछी थी, अभी तो नहीं है क्लास में, कि इसका काम क्या लिखेंगे, रिले का काम क्या है, रिले का काम बोले थे डिस्कनेक्शन नहीं है, डिस्कनेक्शन है सर्किट ब्रेकर का काम, रिले का काम है कोई भी सर्किट को डिटेक्ट करना, ये जब तुमको ये जब मिला ये डिटेक्ट किया, पहला रिले का काम है डिटेक्ट करना, टू डिटेक्ट द फॉल्ट नंबर वन, एंड टू इन्फॉर्म द सर्किट ब्रेकर कि यहाँ पे प्रॉब्लम है, अब इसको ब्रेक कर दो। तो ये एक तो डिटेक्ट किया ऐसे करके, जो प्रोसीड्यूर तुमको दिखा, और जो अलार्म बजेगा जब तुमको फर्दर हार्डवेयर में दिखाएंगे हम लोग का लैब में, देखोगे जब ऑपरेशन कंप्लीट हो तो वहां पे अलार्म बजता है बहुत जोर, दैट अलार्म इंडिकेट्स द सर्किट ब्रेकर एंड द पीपल कंसर्न, मतलब द इंजीनियर्स कंसर्न, कि यहाँ पे फॉल्ट डिटेक्ट हुआ है, अब आओ मेरा काम खत्म, आई एम हैंडिंग ओवर द वर्क टू सर्किट ब्रेकर, उसका वो अलार्म का काम यह है। फिर सर्किट ब्रेकर ट्रिप करता है, ये नहीं ट्रिप करता है, ये खाली डिटेक्ट करके देता है, बस डिटेक्ट करेगा और इन्फॉर्म करेगा नेक्स्ट स्टेप कि मेरा काम हो गया, अब आई एम हैंडिंग द वर्क ओवर टू द सर्किट ब्रेकर। ये हुआ जो अंदर का जो अपर फ्लैप लोअर फ्लैप जो भी था। अब
सर ये वाला वीडियो अपलोड कर दीजिएगा गूगल क्लासरूम में।
ये जितना पूरा क्लास चल रहा है पूरा ही अपलोड हो जाएगा, अंदर जो जो रहेगा सब, ठीक है।
ओके सर।
अब ये देखो, ये तुमको जो गैस का ऑपरेशन बोले थे, कम गैस से ऊपर वाला फ्लैप काम करता है, ज्यादा गैस से नीचे वाला ये काम करता है, उसका आइडिया देगा।
Today we are going to see the operation of Buchholz relay. This is the main oil field transformer and it's a conservative bank. In between these two, it's a Buchholz relay.
साउंड आ रहा है? हेलो?
Yes, sir. In this lecture, we will see the different parts of the Buchholz relay and its operation at different conditions. We have an oil pipe which is connecting the main transformer as well as conservator tank, relay chamber, test cock to collect the gas samples, and these collected gas samples can be tested, which helps in identifying the type of fault. It's a float and a baffle plate.
सर वीडियो नहीं दिख रहा है।
आया है?
कैसे रहा?
यस सर।
ठीक है। अच्छा, यहाँ पे तुम बोल दिया, जब एक चीज बोल देता हूँ मैं। ये जो मरकरी स्विच वाला बोला था कि यहाँ पे दो पॉइंट होगा, यहाँ पे देखो दो पॉइंट ये है कि इसको जब धक्का मारेगा ना, ये इसको नीचे से धक्का मारा ऐसे, ये सीधा हो जाएगा। दिस मरकरी विल गो एंड टच दिस ट्रिप सर्किट, इस पे टच करेगा, ठीक है। तब यहाँ पे सर्किट जो है, जो तुम देखे अभी, ट्रिप करवाएगा। तो मरकरी स्विच का, मरकरी का काम ये है, शायद यहाँ पे दिखाएगा भी। ठीक है, मैं चालू कर देता हूँ फिर से।
Two mercury switches here. One is connected to the alarm circuit, another one is connected to the trip circuit. And these mercury switches play a key role in activating the alarm as well as trip circuits. These are the mercury switches look like. It costs hardly 12 rupees. It's just like any other normal switch, but it can be activated by tilting this. If this is got tilted, this mercury will roll over to here, which will short these two contacts. If you see here, the mercury which is over here, if it is tilted, it has come down here, which is shorting these two contacts. Okay. Now, under normal operating conditions, you just observe the mercury switch position, this position. These two are not activating either alarm or trip circuits. Now, if there is a fault, there are some gases involved in the transformer. As we know, gases are of lesser and denser compared to the oil. So it will try to escape out. And during this process, the gas is trapped over here, which will tilt this fluid down, and hence mercury switch is not activated. It will trigger the alarm circuit. If there is a severe fault, there is a heavy rush of gas, and which will hit this baffle plate. And now this mercury switch is engaging trip circuit. Now trip circuit will activate the circuit breaker. So these are Buchholz relay is going to protect the transformer from its internal faults. As we see here, it can only be worked with the oil filled transformer, because only in oil filled transformer only there are some gases can be generated. And as we see here, it is activated through the gas flow. So hence it is called as gas activated relay. Thanks for watching the video. If you have any questions on this topic, or if you want us to discuss any other topic on electrical, please post in the comment section.
आया समझ? हेलो?
यस सर।
सिंपल गैस का ऑपरेशन। अब दो टाइप का ऑपरेशन, दो ही ऑपरेशन है इसका। एक तो अंदर का जो ट्रिप सर्किट या स्विच सर्किट है वो कैसे काम करता है, जो तुम पहले वीडियो में देखी। अब दूसरा, ये जो सर्किट जो ट्रिप करेगा या ये जो गैस घुस रहा है किसका कारण करेगा? ड्यू टू द लेस फ्लो एंड मोर फ्लो ऑफ द गैस। सिंपल। अब तुम अगर रियल लाइफ में बखौज रिले देखोगे, खाली रिले, सिर्फ रिले, तुमको एक चीज को यहाँ पे समझ में आ गया होगा, मुझको क्या, फॉर द टू सी द ऑपरेशन, ओनली द ऑपरेशन ऑफ द सर्किट, सॉरी ऑफ द रिले, मुझको क्या चाहिए? इधर तेल चाहिए, सिंस इट डिटेक्ट्स ऑयल एंड एयर, एयर बबल्स, ऑयल चाहिए, और एक इंसर्ट पाइप चाहिए जहां पे, जिससे मैं ये कर सकूं, क्या कहते हैं, एयर बबल घुसा सकूं अंदर। बाकी तो इसका काम है। अब इसको क्या मतलब कि ट्रांसफार्मर है कि क्या है, इट डिटेक्ट्स ट्रांसफार्मर टैंक के अंदर से ऑयल आना चाहिए, ज्यादा एयर आएगा तो ये अलार्म काम करेगा, ट्रिप सर्किट काम करेगा। तो इस रिले को अगर सेट करेंगे, सेट करके सेट करेंगे मतलब ये बखौज रिले आ गया, ऊपर जो वाल्व आ गया, अंदर का तो ऑपरेशन अंदर ही है, और इधर से मुझको एक ऑयल कंटेनर और एक अलग इंसर्शन फॉर इंसर्टिंग पाइप फॉर एयर बबल्स, ये मिल जाए तो घर में नहीं, एक्चुअली लैब में ये हम लोग डेमोन्स्ट्रेशन कर सकते हैं टू चेक कि ओवरऑल हम लोग अगर लैब में देखेंगे तो कैसे काम करता है। तो उसका एक लैब डेमोन्स्ट्रेशन का वीडियो तुमको मैं दिखाता हूँ, ठीक है? उसमें भी मोर और लेस थ्योरी है। ये देखो, ये है नया वीडियो आया है स्क्रीन में।
नो सर।
नहीं सर।
रुक जाओ, देखो तो नया रिले दिख रहा है?
यस सर।
हाँ, यही है, ये ऐसे सेटअप है, ये रिले है, दिस इज ओनली द रिले, गैस एंड नॉन रिले, दैट्स इट। यहाँ पे देखो दो पाइप है, यहाँ पे डेमोन्स्ट्रेट ये करेंगे कि रिले के इस साइड में कंजर्वेटर है, जैसे पिक्चर में था, रिले का इस साइड में ट्रांसफार्मर है। पिक्चर लगा दी है क्योंकि अब लैब में तुमको कहां से इतना बड़ा ट्रांसफार्मर कंजर्वेटर लेके आएंगे, सेटअप चाहिए। दीज टू आर द वाल्व्स, ये दोनों वाल्व है, ओपन करेंगे गैस निकल जाएगा ऊपर से। और ये इंडिकेटर है किस चीज का? वो जो अंदर जो फ्लैप देखे थे, बैफल देखे थे, इसका अंदर सेटअप है, अंदर का दिखा दिए। ये इंडिकेटर है कि मेजरिंग स्केल जो होता है कि अप टू ए सर्टेन लिमिट जब जाएगा गैस तो अलार्म ट्रिप कर जाएगा, उसका इंडिकेटर है कि ये, क्योंकि हर एक जो भी रिले है, सिंस इट इज ए मेजरिंग इंस्ट्रूमेंट, को तो मेजरिंग पैरामीटर रहेगा, वो ये है। और ये है दो ट्यूब, इससे हम लोग क्या कहते हैं, एयर बबल बेसिकली घुसेंगे इसके अंदर, हो गया काम। और ये मेरा एमसीबी है। फर्दर यही सब बोल देगा, फिर से मैं तुमको मोटा मोटी सेटअप बोल दिया, मैं चलाता हूँ फिर से, इसको ध्यान से फॉलो करो। और बाई चांस अगर मुझको पता नहीं कितना टाइम बाकी है, बंद अगर हो जाए फिर से घुस जाना, ये खत्म हो जाएगा, तुमको मोटा मोटी आइडिया हो जाएगा, ठीक है? ये चला रहा हूँ।
This demonstration is about Buchholz relay study trainer, model Expo PRT/BRT. Now this is the heart of the trainer kit, Buchholz relay trainer. This is the heart. We can find this relay near to a transformer substation. Transformer diagram we have given here. This transformer we can find in a substation, correct? And this relay also you can find near to that. Now in this trainer kit, the panels that we have used is only one important panel we have used, that is single phase AC input panel EMP16A. It consists of two MCBs for 4 ampere capacity and 1.6 ampere capacity. A fluorescent lamp also we have connected here of 40 watt. That is for if we create any problem, if we create any fault in this relay, Okay, this will give an indication that a fault has been created, and the engineers will immediately come, okay, and they will rectify that fault. And for that purpose, we have put one 40-watt fluorescent lamp. Some connections are also given. Apart from that, we have provided some 2 instruction panels. Make of air pump. This is the air pump MCB2 on EMT 16A. This is the 16A panel. After relay trip, else conservator tank will overflow. Number 2 point is to operate lower float of relay. Close the valve B3 and open the relay oil drain valve B2. Something like that. 2 important instructions we have provided here. And the third is the internal structure of Buchholz relay. Apart from that, this is the important thing. Inside the transformer, we all know that oil is present. Okay, it is filled with oil. Oil is filled for cooling purpose. And if something happens, if some short circuit or overloading happens in the transformer, the air will be created. Air bubbles will be created in the oil. Correct? And that will damage this transformer. And for that purpose, to indicate that, if suppose if that oil, if that air is created inside the oil, for that purpose, we have put this Buchholz relay. It will indicate oil is present, and at that time, the fluorescent lamp will glow. So, as I have already told you, this is in this tank we have filled oil, and there is another tank, a conservator oil tank also. It will store the oil inside this one. There are drain valves also provided for each tank. Also, an air pump. We have provided this is an air compressor. This we are using to put air inside this oil. So at that time, what will happen is that you can see a scale inside this Buchholz relay, that is from 100 cubic centimeter to 400 cubic centimeter. As soon as it reaches the air bubbles present inside this oil, it reaches the relay. From 100, it goes down to 210. And once it reaches to 210, immediately this lamp will glow, saying that a fault has appeared in this transformer and needs to be rectified. Engineers will come and immediately will rectify that fault. Correct? Now I am going to switch on. First 1.6 ampere MCB is already on. Second MCB I will make it on. That is 4 ampere MCB. Now my aim of this experiment is that I will put some air inside this transformer. Correct? I have switched on. The compressor is also on. And air will fill inside this tank, correct? And now one important question you will ask, that what is this non-return valve? Non-return valve is a pneumatic component, and we have used it here. That is because the oil should not enter inside the air pump or something like that. Only air should go down. Air should pass into this oil. Correct? For that purpose, we have used this non-return valve. It is written here, NRV. As I have already told you that I have switched on this air pump compressor. Now you can see the air bubbles passing through this tube, correct? Into this relay, correct? Into this relay. And you can see the scale also, it has reached up to 100 cubic centimeter. Now, as soon as it reaches to 110 cubic centimeter, this, as I've already told you, this lamps will glow. Let it reach 210 cubic centimeter. And I wish to tell you some other points like that. This is that this valve should be kept open during the experiment. There are two rotary valves also given on this Buchholz relay. That should be made it off. You have to keep it off position. And this should be kept open. That is of this one should be kept open. Now it has reached around some 150, and very shortly it will reach 210 cubic centimeter. Air bubbles are passing through this pipe. You can see it, and it is reaching near to 200 cubic centimeter mark. It has crossed, it is going to cross 200 cubic centimeter now. It is taking some time for this lamp to glow, and it has crossed 200 cubic centimeter. As you see, it has reached somewhere 210 cubic centimeter, the soil, and the lamp has glowed. Correct? This indicates that a fault has been created, and engineers will come immediately and they will rectify this fault. Correct? This is the first experiment. This is the most important experiment which we can study in Buchholz relay study. Second fault also is there. You will ask only, is there one fault in the strainer? There is second fault also. One other fault also is there. Now, how to make it off? How to take it off? So you have to just release this gas. Just release this gas, and the oil will reach up to 100 cubic centimeter, and the lamp will be made off. For that purpose, is to gas relief valve to be there, and I'm just making, and just now what I will do is that if I will make it, I will shut it, then again that fault will appear. I will make this MCB down. I'll put this MCB down, 4 ampere MCB, which has switched on this here. Correct? I've made it off, and I will shut this gas relief valve. Correct? The gas is still present, and we are removing the entire gas. Correct? It has crossed, it has gone about 100 cubic centimeter. Now another fault also we can create, and that is what will happen if there is a leakage in the oil inside the transformer. If there is a leakage, the entire oil will go. Okay, and at that time what will happen? Correct. So for that purpose, as I have already told you, that I have switched on this air pump compressor. Now you can see the air bubbles passing through this tube, correct? Into this relay, correct? Into this relay, and you can see this scale also. It has reached up to 100 cubic centimeter. Now, as soon as it reaches 210 cubic centimeter, this, as I've already told you, this lamps will glow. Let it reach 210 cubic centimeter, and I wish to tell you some other points like that. This is that this valve should be kept open during the experiment. There are two rotary valves also given on this Buchholz relay. That should be made it off. You have to keep it off position, and this should be kept open. That is of this one should be kept open. Now it has reached around some 150, and very shortly it will reach 210 cubic centimeter. Air bubbles are passing through this pipe. You can see it, and it is reaching near to 200 cubic centimeter mark. It has crossed, it is going to cross 200 cubic centimeter now. 200. It is taking some time for this lamp to blow, and it has crossed 200 cubic centimeter. As you see, it has reached somewhere 210 cubic centimeter, this oil, and the lamp has glowed. Correct? This indicates that a fault has been created, and engineers will come immediately and they will rectify this fault. Correct? This is the first experiment. This is the most important experiment which we can study in Buchholz relay study. Second fault also is there. You will ask only, is there one fault in the strainer? There is second fault also. One other fault also is there. Now, how to make it off? How to make it off? So you have to just release this gas. So just release this gas, and the oil will reach up to 100 cubic centimeter, and the lamp will be made off. For that purpose, these two gas relief bulbs we have, and I'm just making, and just now what I will do is that if I will make it, I will shut it, then again that fault will appear. I will make this MCB down. I'll put this MCB down, 4 ampere MCB, which are switched on this end. Correct? I've made it off, and I will shut this gas relief valve. So gas is still present, and we are removing the entire gas. Correct? It has crossed.
हेलो हेलो
Yes, sir.
यही था मोटा मोटी, सब खत्म हो जाएगा। 1 मिनट बाकी है इसका, मेरा वीडियो का भी 1 मिनट बाकी है। कोई डाउट है यहाँ पे किसी का?
No, sir.